Hello all. So welcome back to live streaming. And as you know, in this course, we'll see all the basics about Kotlin. And this time we'll go through functional interfaces. If you really like these videos and want to learn more about Kotlin and have an in-depth course, please follow my course and subscribe to the channel. This is going to be about a topic that actually I have not used in Kotlin, but we'll have a look at it, and then we'll see if we have time for visibility modifiers. So, what are functional interfaces? An interface with only one abstract member function is called a functional interface. So it has only one abstract member function, like this one, or a single abstract method SAM. So this is why it's called SAM interface. It has two names basically: functional interface or single abstract method interface. And the functional interface can have several non-abstract member functions, but only one abstract member function. So there can be non-abstract member functions, but only one abstract member function. To declare a functional interface, use the fun modifier. So we can try to declare this in here. Maybe we'll create a new fun interface.pt, and then we'll call this fun interface a runnable, and then we'll create the method invoke like they're doing here. Okay. So for functional interfaces, you can use SAM conventions that help make your code more concise and readable by using lambda expressions. Okay, so this is the idea of all this. And instead of creating a class that implements a functional interface manually, so a class that implements a functional interface manually, you can use a lambda expression. So with the SAM conversion, Kotlin can convert any lambda expression whose signature matches the signature of the interface's single method into the code, which dynamically instantiates the interface implementation. So for example, consider the following code. And here we have the function accept. So we have a functional interface int predicate and a function accept, which returns a boolean in case an integer is given. And if you don't use a SAM, you will need to write this code, a SAM conversion. So let's try it. Maybe this example is better than runnable. Copy, paste, and maybe just int predicate, and we'll call this file like this. Then we go back to our classes, and here what we need to do is we need to create an object which is inherits from integer predicate, and then we need to override the function. And if we say we want to accept the boolean, we'll do it only if the boolean is divided by 2, doesn't have is not floating number, so it's an integer number. And sorry, an unsigned integer number, positive integer number. So let's try and create an instance of this class. We'll do it from scratch. So val is even, yeah, so basically this function will check if the integer that we're giving is even, because that's what the modulus operand will do in this case. So yeah, it's not about what I was saying before, sorry. So val is even object, and then we have to inherit from int predicate, and then we have it will say that we have to implement the members, and then we have to return I divided with modulus of I have the non-encoding. Okay, 2 equals 0. So this will check if the number is even or odd. If you want to, yeah. In case of odd, we'll have a false. And then what if we do is even, and we try and create parentheses? Yeah, it will say that cannot be invoked. So the way we have to invoke it is by passing the number like this. So let's do this. Accepting number, and then okay, very good. Then next, by leveraging the Kotlin sound conversion, you can write it with an equivalent, which is int predicate equals, and then yeah, int predicate, and then we passed predicate inside. So I guess this is something very interesting, because we can rewrite the whole syntax here. Val is even Sam with int predicate. As you see, it's also suggested by the IDE, and then we can say hit divided with modulus by 2 equals 0, and this will be the same as our function defined with the object. So yeah, as you see, they're also suggesting me to convert the expression to the lambda function. So yeah, this is actually a lambda function that does all the job by itself. And the thing you notice here is that you don't have the accept. It will automatically understand that there is one accept here. So that's interesting. That's the magic of these lambda functions in functional interfaces. A short lambda expression replaces all the unnecessary code. So yeah, you see here, that's what we have done as well. Let's try and run it. Run. And then let's see what's happening in our IDE. So starting from Kotlin, yeah, from 1.6.20, Kotlin supports callable references for functional interface constructors, which adds a source compatible way to migrate from an interface with a constructor functional to a functional interface. Consider this code, blah blah. So this is interface. Okay, we have an object which overrides the function print and okay, passes the block function. With callable references to functional interface constructor enabled, this code can be replaced with just the functional interface declaration. So yeah, this is the same. And its constructor will be called implicitly, and any code using the printer function reference will compile. For example, document storage add printer, and then passing printer Okay. Preserve the binary compatibility by marking the function printer with the deprecated. Okay, this is not very clear, I have to say. But let's see. Yeah, our code is not running. Let me check why. A result reference, okay. We are not importing the function. This is not very clear. Migration from an interface with a constructor. Because they're not showing what add printer does. So the add printer, I think, will be passing a printer function. I mean, it would have been better to have the whole source of the example like this. It's a bit hard to understand. Okay, our code did run and it runs successfully in both cases. So that's good. And let's see what they said here. We'll skip this migration. You can also simply rewrite above code using a type alias for a functional type. Okay, so a type alias for int predicate, and we can say this is equal to so we have an integer passed in the function, and then we return a boolean. So the argument is an integer and the return type is a boolean, and this is a type alias for a function. And then functional interface actually. And then what we're seeing here is val is even is equal to the function. So our predicate is the same as before, and this way when we call is even and we pass the argument without even specifying the except as we did in the first example, then where the first example? Yeah, it's in my code. That's why we don't find it. Yeah, it's here. Then it will run successfully. Okay. Yeah, here. Sorry, I couldn't find it. Okay, so let's try this syntax. Let's call these fun. No, it's not fun. It's type alias of type alias, then int predicate alias, and then we say this is equal to we have our integer and we return a boolean. And this way, what we can do again here is we can say val. Okay, let's do it over here. Val is even type alias, and then we say is even. Oops, sorry, predicate alias, and then we say okay, we want our predicate to be the same as before, so I, and then I divided modulus 2, sorry, and then equals 0. And this way, if we call is even type alias, we should have the same result again. Is even type alias, and we pass in the 4. And what's interesting here is that, yeah, if we pass the pointer here, we'll see that this is a type alias, and if we pass over type alias, we can see that we're passing an integer and we're having a boolean as in return. Okay, so that's good. What we could do is we could say also is odd type alias. So this is the flexibility that we have here. And let's do something like is even, and here we will have is odd. So is odd type alias. And let's run again. And now we should have our proper results. So yeah, 4 is an even number and not an odd number. Let's read this very quickly. So, however, functional interfaces and type aliases serve different purposes. Type aliases are just names for existing types. They don't create a new type, while functional interfaces do. So the type aliases are names for existing types. Okay, let's type this down. Name for existing type, while functional interfaces create a new type. They create a new type. Okay. You can provide extensions that are specific to a particular functional interface to be inapplicable for plain functions or their type aliases. So yeah, that is the very specific usage. Type aliases can have only one member, while functional interfaces can have multiple non-abstract member functions and one abstract member function. Functional interfaces can also implement or extend other interfaces, so that's cool. Let's try and do something like a font interface x predicate extension, and we call these accept decline integer. Let's see what happens. So, and now we can say, since we can follow the suggestions there, we can say that, yeah, okay. What you can see here is that functional interfaces must have exactly one abstract member, and so we cannot have an abstract member here. Let's try and see how to have a non-abstract member. Let me think. I will check very quickly how to. All right. So the non-abstract means just that they have an implementation. So if I do this, yeah, okay. So yeah, I think we should do it like this. So return. This way, you see that we can have actually we can have a non-abstract member like we do here, and here we have an abstract function, and this way it's allowed by Kotlin. So yeah, maybe I'm thinking about a possible use case, but it's a bit hard, I have to say. Maybe because yeah, we would need to use this probably this function maybe inside accept, or we just use it over here. I don't know. It's a bit odd. This could be like a printing function, maybe. Let's see. Like printing your number is I. Then we could do, okay, we have our integer predicate, and in this case we can only use it here or there. So is even, if we do is even, then we can also do printing and we can pass in the number 4. And this is allowed. Or is even sem, and we cannot do this with the alias because the alias is a name for an existing type. And we would have to do something different. Okay, so it does not provide an implementation. So override. But wait, so exception receiver lambda does not define or inherit an implementation or result a method abstract void printing or interface or yeah, integer predicate extension. So I guess we need to also override the function here. Let me try printing, and we call the super. This should work. Let's try it out. I think it will crash on the isSem. Okay, it did run here, but I was a bit stupid because we should, yeah, maybe you should return an integer string, sorry. This way it makes more sense. And now should be good to go. Let's see if the first one goes okay. Yeah, it goes okay. So we're providing now an implementation of the interface and it's working well. And second, if we want to do it here, are we allowed to or no? Oh, that's interesting. I think we're not allowed here with this syntax. It's even sense. If I do printing, it will, yeah, it will crash because it crashes below. So other solutions. In this case, I think you cannot override the interface implementation. I think that's not possible. I would have to check. So double check if we can override printing function here in stem interface. Override. Let me try and see what we have on the internet. But yeah, only works with interfaces that have a single abstract method. So this cannot override. Sem cannot override printing. So that's the difference between the two. And also these type aliases. So type aliases don't create a new type and cannot override printing. They're not even, they don't have the printing actually, so it would be impossible. The only way you would have to you could do that is by overriding it there. So it's an issue that the IDE is reporting this override as redundant because it's not. All right. So now if we remove that, it will run fine. Perfect. Good. So we're good. We're done with that. Functional interfaces are more flexible and provide more capabilities than type aliases, but then they cost more both synthetically and runtime because they require special conversions of a specific interface. When you choose which one to use in your code, consider your needs. Your API it needs to accept a function with some specific parameter or return type to a single functional type or define a type alias to give a shorter name to the corresponding functional type. If the API accepts a more complex entity, for example, it has non-trivial contacts or operation, it can be expressed in a functional type signature, declare a separate function interface for it. Okay. Let's go on with the visibility modifiers. So classes, objects, interfaces, constructors, and functions, as well as properties and their setters can have visibility modifiers. Getters always have the same visibility as their properties. So that's interesting. There are 4 visibility modifiers: private, protected, internal, and public. The default one is public. And let's see all their possibilities. I think we already discussed about it. So we'll go quickly through them. Packages, functions, properties, classes, objects, and interfaces can be declared at the top level directly inside a package. Okay, so you can directly create a function, a property, a class, or an object, and interfaces at the top level directly inside the package. If you don't use a visibility modifier, the public will be used by default, which means that your declarations will be visible elsewhere. So, test visibility of G. So I'm declaring this inside here, inside another package, just for testing. And then we have function paths, and then we'll have plus bar. Okay. Yeah, it must have a body. Okay. So if I try and call this visibility test, visibility. Oh. Visibility. What we can do is call .bas, right? We can, because it's it's a public class, a public function. And if we declare it as private, we cannot call it. Oops. Mess. We cannot call it. Yeah, we have to mark it either as internal, which means it will be visible everywhere in the same module. So visible in the same module, internal, visible in this file is private, and I would say, yeah, protected, not available for top level declaration. So what this means is that, let's see an example with the protected. So yeah, as you see here, the nested cannot be seen, can be seen by outer, but it shouldn't be, well, yeah, protected B, BC and D are visible, and sorry, let's see, protected means that the member has the same visibility as one marked as private. Yeah, okay, because here they're calling, probably there is a little difference between Yeah, means that a member has the same visibility as private, but that is also visible in subclasses. So yeah, so if you have a class that inherits from an open class, you can still see the protected stuff, but you cannot see these outside of subclass probably. So let's try and see protected function. And then we have class. So generate an example with class. So I'm generating a quick sample, just not like this. Okay. Generate a class and in Kotlin and a subclass. So we'll take a quick example from ChatGPT and we'll push it to our code here. Okay, so we have start engine, electric car is a vehicle, and it has all the brand, model, year, and battery capacity. And we call, since it's an electric car, only it will have capacity, and the vehicle does not have by default the capacity. So we can call start engine, and this will be overridden 2 times. So then we'll call a function like protected on get brand and model, and we just say this brand model is going to be this string yeah, it's in parentheses. That's very good. And we can call this is protected, all right? So we call this here, and we call this here. Now what I want to do, yeah, let's try and call this from the interface internal function paths. And yeah, like create vehicle, electric vehicle. Okay, and then we say, okay, we create an instance of electric car, and then we give it some values like this. All right, then we say electric car dot start engine, and we say electric car dot get brand and model. And as you can see here, since it is protected, it's only available on top level declarations like electric car, and it's available only here and here, inside vehicle and inside electric car, and not elsewhere. So that's the difference with the protected. All right, very good. Then yeah, you can have also, as you see, class members, they will behave probably the same. And also, so if I try and do it like this, brand and model, or maybe here, let's get there here, like here, okay. Maybe we say year string, and we just return this. Yeah, and instead of a function, we return a value, right? And here we say parentheses, year string, and you do the same here. But what if we try to invoke it here, electric car dot year string, then we cannot access this, same as before. We would have to do something like either internal or public. Oof. Okay, and this way we can access it here. Oops, electric car dot here. Okay, very good. Let's run these. Okay, we have something failed and reserved reference paths. Oh my god. App. Create function. Yeah. Let me check something over test visibility, create EV. Okay, we have changed it to create EV. That's good. So as you see now, it's running fine because we changed the visibility to the proper one. Yeah, you should always choose the more strict visibility modifier. That's the safest option. But okay, use the following syntax to specify the visibility of the primary constructor or class. So it can be, yeah, private, public, so blah, blah, blah. Same thing. And the internal, same as we just said, it's inside the same module. So if you have two different packages, you could still call it from a different package. So for example, if we wanted to call all of that directly from app. Could do this, as you see, because we're inside the same module. So the package, that doesn't matter. It meant the modules, the module app is the same, so you can use the reference to year stream also here. An app. Okay, so since I'm a bit tired today, I will close it here and thank you guys very much for watching. I hope it was very useful for you. Next time we'll go through extensions, which are very useful. Extension functions are very useful in Kotlin, and then we'll see something more interesting probably here. And then we'll have a deep dive into data classes. This will be also interesting. And then seal classes and so on. Then generics, nested. And yeah, we still have a lot to go. So I hope you guys will love this course. And of course, I didn't specify it, but if we gain more traction, we can go also with multi-platform development, and that will be, of course, very interesting for you, I think. So thank you guys for sticking